class, today's lesson is exercise 8C, the addition rule. So what is the addition rule? The addition rule is used to determine if two events are mutually exclusive, and it helps us to find probabilities. This is the addition rule. Please copy it into your workbooks. So it states that the probability of A or B, so A or B, that's this whole section here. So the probability of A or B equals the probability of A, so this is A, plus the probability of B, so that's the whole circle of B, minus the probability of A and B, so that's the overlapping intersection there. So the reason why this is subtracted is because otherwise the middle part would get counted twice. If we added the A and the B, the middle part is there twice, so we subtract the middle part, so it does equal the probability of A or B. So I'll just explain the rule with an actual example. So the rule is probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay, so with this example here, the probability of A, so A is this section here. So A, there's 6 plus 4, so there's 10, plus the probability of B, so B is this, 4 plus 5, so 9, minus the probability of A and B, so that's like the middle section, so that's like this here, so minus 4. So if we work that out, 10 plus 9, 19 minus 4 is 15. So to work out if that's correct, so A or B, so that's basically like this whole, section here. So we add them all up. So it would be 6 plus 4 plus 5. Yep, that equals 15. I just wanted to remind you guys what mutually exclusive means. So it means there's no elements in common. So in this middle section here, there's nothing, 0. So it can also be drawn like this second Venn diagram, no overlap at all. There's nothing in the middle. So please copy this into your books. If A and B are mutually exclusive, then the probability of A and B equals 0. So that's like saying this middle section here is 0. Also, if A and B are mutually exclusive, then the probability of A or B equals the probability of A plus the probability of B. If they're mutually exclusive, we don't need to subtract the middle part because there is no both. There's no section where there's an overlap. This example is similar to a few that are on the test. So two events A and B are such that the probability of A equals 0.4 and probability of B equals 0.8 and probability of A or B equals 0.85. Find the probability of A and B. So the first thing to do is write out the addition rule. So probability A or B equals probability of A plus probability of B minus probability A and B. Next step, I need to substitute in the values. So they're in the question. So A or B, that's listed as 0.85. A is 0.4, B is 0.8, and we don't know what A and B is. We're trying to figure that out. So I'm just going to write it, I'll just add those. So 0.4 and 0.8 is 1.2. Okay, so now what I'm going to do is I need to solve. So I'm going to solve using inverse operations. So what I'm going to do is I'm going to add this to the other side. So plus PR, A and B. So I've got PR, A and B plus 0.85 equals 1.2. And then I'm going to subtract this. So the opposite of plussing is subtract. So subtract 0.85. So therefore, probability of A and B is 1.2 minus 0.85. So that equals 0.35. I'm going to show you a second example. Two events A and B are such that the probability of A equals 0.9, the probability of B equals 0.6, and probability of A or B equals 0.7. Find the probability of A and B. So first thing to do is write out the addition rule. Probability A or B equals probability of A plus probability of B minus probability of A and B. Okay, next I substitute in values. So A or B is 0.7. Probability of A 0.9, B 0.6 minus the probability of A and B, which we don't know. Then I rewrite it out by simplifying this. So 0.9 and 0.6, 1.5 minus PR A and B. Okay, now I solve. So I'm going to plus this to the other side because opposite of minus is plus. So plus A and B. So I've got PR A and B plus 0.7 equals 1.5. Then I subtract this to the other side. So probability of A and B equals 1.5 minus 0.7, so equals 0.8. Last example. A card is selected from a standard deck of 52 playing cards. Let A be the event the card is a diamond, and B be the event the card is a jack. So I put in the deck of cards, but lots of you guys don't seem to know what they're like. So the probability of A is that the card is a diamond. So diamonds, this is like all the diamonds. So there's 13 altogether. So 13 out of, there's 52 cards altogether. Alright, the next one, so that was a diamond. The next one is the probability that the card is a jack. So these are the jacks here. So there's 4 jacks. So 4 out of 52. Then the probability that the card is A and B. So that means that it's a jack of diamonds. So jack of diamonds, there's only 1 here. So 1 out of 52. We're going to use this for the next question on the next slide. So now it says use the addition rule to find the probability of A or B. So the addition rule, I write it out, A or B equals probability of A plus probability of B minus probability of A and B. Substitute in the values. So this time we're trying to find A or B. We know probability of A is 13 out of 52, B 4 out of 52, and A and B 1 out of 52. So now I just add those fractions. So because the denominator is the same, the bottom of the fraction is the same, I can just add and subtract like normal. So 13 plus 4 is 17, minus 1 is 16. So 16 over 52. That's a probability of A or B. I would like you to complete this worksheet and submit it to my Panola.